Math 150 Applied Calculus students. How are you? This is section 4.1, and we are going to show, or I'm going to show you what the first derivative does for us, and next time we'll see what the second derivative does for us. So the first derivative talks about increasing, decreasing, and local extrema. That means local max or min. And I'm going to use a pencil today. I need a pencil. Okay, here we go. Recall that the first derivative, f prime of x, measures the slope of the curve, f of x, at x, at a point. All right, so what we're going to do is just get an idea of what max and min are. So we're going to look at this graph here. And you can pretty much use your intuition as to what does increasing, decreasing. So it says, number one, let me get together here. Identify the intervals on which f is increasing. Then number two says, identify the intervals on which f is decreasing. Right? Increasing and decreasing. So we're going to use our instincts on this one. You always go left to right. That's the order of increasing x. Right? X increases as we go this way. And notice that if we start at this x value of a, that this is, the function is increasing. Then it gets to this point. Then it decreases to this point, and then it keeps decreasing to that point, and then it increases to that point, then it decreases, and then it increases, and then it increases. And what we're going to do is talk about the intervals over which the function is increasing. Well, the function's increasing, and the part of the domain, now notice that the domain goes from a to h, and the part of the domain over which this function is increasing, that's how we say it, over which the function is increasing, is from a to b. Then it decreases the function from b to c. Now at c, there's kind of a spot where it's no longer increasing or decreasing there, so it's decreasing and then it kind of stops and then it decreases some more. Then the function increases from d all the way to f, and then the function decreases from f all the way to g, and then the function increases from g to h. And we're going to write this formally. So I'm going to come over here and take a look at my notes. So this is how we write this. We say that the function, so this is the answer to 1. Function is increasing, open, a to b, that is an interval, and this means union. I actually wrote this down here. Parenthesis d comma f, union g comma h, parenthesis. So that is how we write increasing from a to b. So we just go open a to open b. So open, what I mean by open is that it's not increasing or decreasing at that point or at this point. Now I'm going to show you that open is with parentheses, and then if I come down a little bit longer, bracket means closed. Okay, so the bracket is closed. Okay. I don't know if you remember this from long ago, but we're just going to always use open on increasing and decreasing intervals. And I can't remember if Math150 uses commas or unions, so just in case, you can put commas in here because Math150 may use commas there. All right, now part B wants to know where the function is decreasing. And you should pause this and try to write where the function is decreasing. And the answer is, and I'll just do it with unions, b comma c, union c comma d, union f comma g. I'll talk more about the c, why it's split up at c when we get a little bit further. All right, now 3 says identify the intervals on which f of x is greater than 0. So that means where the function's derivative is positive. And remember that the derivative measures the slope of the curve. So we are talking about where the slope of the curve is positive. So the slope, remember, and I'm going to try to draw this, is if I take a point right here, let's say, that slope is going uphill. If I take a point right here, the slope is uphill. But over here, on the decreasing, the slope is going downhill from left to right. Downhill. This one, downhill. So we're looking along this curve, thinking about this tangent. And then what about this one? At this point, the tangent line is horizontal. Up here, the tangent is horizontal. Okay? So we're going to try to follow this tangent line along this curve. Here the tangent line is going uphill. Here the tangent line is still going up to a point, and then the tangent line is horizontal. Then the tangent line is downhill, downhill. See, look at the slope. It's going downhill from left to right. And then here, downhill. And then at this point, you kind of have a down and then a up at the same time. And we would say that the slope of the tangent is undefined there. Okay. Here the slope of the tangent is 0. So that means f prime equals 0 there. The slope of the tangent is 0 right there. The slope of the tangent is 0 right here. Okay, the slope of the tangent is 0 right here. And notice I'm putting f prime. At this point, the slope of the tangent sort of has a double thing going on, and we would say that f prime does not exist here, or is undefined. Does not exist right there. And over here, so we're analyzing the graph, this slope, or the derivative, does not exist. Okay, at that. And these are called corner points. When they have corners right here and they're not smooth like here, where the derivative is 0, we call it the slope is undefined, derivative is undefined. Now, look along this edge, you know, it's the slope of the tangent, it's the same, it's positive. So all of these little marks that I've made along here are my tangent lines. Derivative doesn't exist. Here your f prime is positive. Okay. Here your f prime is negative in here. I should have made a bigger graph. And f prime is positive to here, then f prime is 0, and then notice the slope of the tangent. And then at this point, does not exist, but here it's negative and then positive again. All right, so that was the analysis. Let's take a look at, it says number 3, identify the intervals on which the derivative is greater than 0. And that means positive, where the derivative or where the slope is positive. And the slope is positive, notice where the function is increasing. Here in the function, the derivative is negative. Here the derivative is positive. On an increasing. Here, look at those slope lines. Those are negative, and here we've got f prime is greater than 0. Okay. So really what they're asking is the same thing. Identify the intervals of where the f is increasing. And then notice that this is going to be where's the derivative negative. And they're trying to give you a connection between the derivative and increasing, here the derivative decreasing. So the answer to 3 is the same as 1. And I have written that down. So that f prime of x greater than 0 means the slope of the curve is positive. And it also means that the slope is, or that the curve is increasing. So it's the same answer as A, number 1. And then number 4, it's the same answer as number 2. We're looking at the derivative is less than 0, which means negative. It means the slope of the curve is negative. It's going downhill. And so the answer is the same, and I did not write that. So same answer as, which one? Number 2. And if you look at number 2's answer, remember the split between at the C? There's a split because the function is, or the derivative is negative, then the derivative is 0. then the derivative is negative again. So there's a gap between those two, a little teeny tiny point, but we do make sure that we separate those. All right, I'll come back and finish this.